Welcome to the 12th lecture of Logic and Distributed Control System. So today we are going to discuss about the PLC counter functions. So last lectures, the couple of lectures we have discussed about the PLC timer functions. So the objectives of this discussion at the end of this chapter, you will able to describe the PLC counter functions and list some of the major counting function used in circuits and processes, apply the counter function and associated circuitry to process control, and you can apply combinations of counter and timers to solve the process control problem. So as an introduction, PLC counters have programming formats which are similar to the timer formats. One counter input furnishes count pulses which the PLC function analyzes. Another input usually carries the enable reset. Alternatively, there can be separate inputs for enable and reset depending on the application requirement. Most PLCs contain both up and down counters which function similarly. Some PLCs also include a combination of up-down counter is one function. Then there must be a flag by which you can control whether the particular counter will act as a up counter or down counter. Means suppose if you make flag equal to 1, it may work as a up counter. If you make flag equal to 0, then it will act as a down counter. So some of the typical application of the counter has been shown. That is, here you can see that suppose if we have a tea packaging industry where you can see that the tea packets are packaged inside a box. Suppose in a day we want to count that how many boxes are packaged. So then what we have to do in a conveyor belt through which the tea bags or tea packets are passing, then here one transmitter receiver arrangement we can do, which can be thought as a, suppose as a transmitter we can keep a LED, and here as a receiver we can have a phototransistor. So whenever a tea bag is going to pass through this sensor arrangement which is acting as a transmitter receiver, then one pulse will be generated. So if we want to count the number of boxes, so definitely if the box is going to pass through this path, then definitely that many number of pulses is going to be generated. So using counter we want to count that number of pulses basically. So a counter is programmed function that counts or increments every time input changes from false to true. That this means that if in one scan the input is false, the next scan the input is true, the counter increments. So this is the way the counter is going to work. The counter used in PLC to solve the same function as mechanical counters. Counters compare an accumulated value to a preset value to control circuit functions, and control applications that commonly use counters include the following: count to a preset value and cause an event to occur. Means suppose after counting certain number of pulses, that suppose a motor is going to on, so then this kind of operation we can do using counter function. Count to a preset value and cause an event to occur. Another application can happen: cause an event to occur until the count reaches a preset value. Means once we will reach to the preset value of the counting, then the event is going to stop. Something like that if you want to implement, then we can have the counter. A bottling machine, for example, may use a counter to count the bottles in a group of 6 for packaging, which is indicated in the figure. So another application, suppose here, so if we want to, suppose here apple packaging industry is there, so through the conveyor the apples are coming, we want, suppose we have fixed that in a box 10 number of apples will be there. Fine. So here that's why the sensor arrangement has been given. Whenever the apple is going to drop, okay, so maybe after 6 number of apples, this conveyor belt is going to stop momentarily. And how you are going to count the number of apples? Here that sensor arrangement is given, which is actually going to create the pulse. So and also if we want to count the number of boxes, that is also possible by installing another transmitter receiver sensor arrangement by which we can create the pulse. So in this way we can count the number of apples as well as we can count the number of boxes also. These are the several application you can find in the industry. So now we are interested to know what will be the common format for the counters we are going to use. So as earlier for the timer we have used the block format, so PLC counters also we are going to use the block format. So this is the block format where you can see that one input here, one input IN001 is responsible for count. Means basically this IN001 is going to receive the pulses. Fine. So here you can see that preset value is 21, and there will be IN002 which is enable reset, which may be the multiple contacts, means you can use the separate enable reset contacts, but here it is IN002, and the format is that here it is written UC17. So this is coil for the counter. If it is a down counter, you should write DC17, something like that. So you when you are going to develop the programming, you should use the format for the counter as well as the timer. The formats are very important. If you don't write UC or DC, it will be not clear that what kind of counter is you are going to use. So the preset is where the count value is set. It may be constant or designated register. So here the constant value has been provided, that is 21, or this content or preset value can be decided by the content of another register. So this kind of application we will see later on. And here HR102 is the designated register in which the counter take place. Actually it is going to increment. So whenever the IN002 is closed, now the counter will be enabled, and whenever this IN001 is going to get the 21 number of pulses, then the UC17 is going to be energized. Means suppose the IN001 by the sensor it is going number first pulse, then the content of the HR02 will be incremented by 1. So like that, whenever this content of HR102 is going to be equal with the preset value 21, then we will find that the UC17 is going to be energized. Fine. And if you withdraw the IN002, then what it is going to happen, the counter is going to be reset. So now here another important thing is that when the preset value is reached, the output UC17 is going on, and if it is an up counter, the counter starts at 0 and increments by 1 each time IN001 is pulsed on. Okay, as the count goes on beyond the preset value, the output stays on. Means suppose here if you are getting more than 21 number of pulses, still the UC17 is going to be on. Fine. The opening IN002 at any time resets the counter to 0. The down counter operates in a similar manner. The count starts at the preset value and decrement by 1 each time, and input IN001 goes on. When the count reaches 0, the output goes on. Means here in that case the register HR102, the register value will be the 21, and when we are using DC down counter, and whenever it is going to receive a pulse, then the content of the register is going to decrement by 1. So now whenever it is going to be 0, then only the UC17 is going to be energized. Okay, so this is the way it is working. You see, when the count reaches 0, the output goes on. Fine. So now we can use a coil format also, but in this course we are not going to use the coil format, but if you are interested to understand, you can go through this slide. And here for your convenient, that Allen Bradley counter format is also shown. So here you can see that I12 is the input. Each time the input goes false to true, the processor increments by counter 1. And here you can see that it is a count up, means up counter, and the counter address is C50, preset value is 4, and accumulator you can see it is 0. Now whenever here you can see that one done bit is there, or it is also indicated by a switch, that is DN, or contacts we will say, that is C50, which is the counter address, tells when the count is reached. Accumulator, which is accumulated value, will be greater than or equal to the preset value. Then this output 20 is going to be energized. Okay, here this is for the overflow, that tells when the counter overflows, then only this 21 is going to be energized, and this I17 is going to reset the counter. So this is a special format which is used by the Allen Bradley. So as I told that this course we are not going to use any kind of format provided by any of the manufacturer. We are going to use the general format which will be used for programming the PLC ladder diagram using these counters. Okay, so now in some application you may wish to stop the count for time without it resetting to 0. In that case, what you have to do, you have to use the separate switch for enable and reset. Means suppose you want to stop, suppose after receiving 5 pulses, here preset value is 21, after receiving 5 pulses you want to stop the counter, so then just you withdraw the enable input from IN002, then the counter is going to stop at that point of time. But if you reset it, then counter is going to reset to 0. Okay, depending on the down counter or up counter what you are using. So so that's why we can use the enable reset switch separately. Fine. So the industrial application, let us create the theme that straight counting in a process. The counter output goes on after a set count is received by repetitive pulses to the counter input. Okay, so as I said you that whenever you are doing the ladder programming using the count, especially the counter as well as the timer, you should use the the timing diagram. So here you see up counter and down counter has been shown. So first you have to enable, whenever the enable, you have enable the switch IN006. okay, so suppose that IN006 is enabled, so this is the IN006. Once it is enabled, okay, the counter is now in operation. Preset value is 18. Now you see the first switch IN004 is responsible for counting. So now this IN00, what is the address? That is let me see, 004. So IN004 is going to receive the pulses. Okay, so now here I am going to give the dots. So now suppose this is the 18 pulses it has received. So what will happen during this pulses when it is received by the counter, that is the CR21. So CR21, so we are writing the CR21. CR21 is going to be off, and when it is going to receive the 18th number of pulses, at that moment of time it is going to be energized. Okay, and even if it is not going to receive any pulse, that is IN004, that still it is going to be energized. So this is the way it is going to, so this is the moment. Fine. And the same way the down counter is going to work. Now we are going to give you certain example to understand the counter operation. So suppose a counter is to be used to count objects in the conveyor delivery system, or the system which is shown in the figure. Show how a counter can be set up to count 10 objects and then turn off the conveyor motor. So here you see in on a conveyor belt, 10 objects are there, objects are passing, and whenever the 10 objects will pass, then this motor is going to be stopped. So how we can develop the ladder diagram or ladder logic for this? So here you see we are using the counter. Here little bit mistakes, one mistake is there. Here you can write that is CR32, the output of the counter. So now here this is the count, okay, and this is the reset and enable. You should write correctly what the use of switches, okay. So and the preset value, here you see, suppose you have given 10, okay, 10 you have given the preset value. So here actually it is not shown correctly the format, so we should write it is up counter. So okay, so up counter we should mention. So now whenever the 02 is closed, then what will happen, that if the IN001 is going to receive the 10 number of pulses, and during that the motor, so this is the motor, so during that motor is going to run because it is normally closed, okay, and because during this 10 number of pulses CR32 is not energized, so that's why what will happen, the motor is going to be on. So after receiving exactly 10 number of pulses, this 32 is going to off, because this logic is going to false, then motor is going to off. So in this way you can execute this logic, fine. Now another application, that is dual counter application. Suppose that we wanted an output indicator to go on when 6 of the part C and 8 of the part D are on a conveyor. This circuit would monitor the proper counts. IN002 and IN003 are the proximity devices that pulse on when a part goes by them. To repeat the process, turn IN001 off to reset the system, then reclose IN001. So here you see the conveyor belt having 2 paths at the beginning. So here actually suppose 2 proximity switches are there, okay, which is indicated by IN002. Here another is there which is indicated by IN003, fine. So now if you can so now what will happen, that whenever the object is going to pass through this path, then one pulse will be created. And what the demand is that whenever 6 and 8 number of devices or the packages are going to pass, then we should turn on a indicator. So now suppose this is the logic. So this is the IN001 is the master switch and CR17 is the master relay. So whenever IN001 is energized, CR17 is going to be energized, and we are using 2 counters, that is the and corresponding preset values are 6 and 8, fine, and both are off counter, and which is whose output coil is CR18 and CR19 respectively, fine. So now whenever IN001 is closed, so this one also will be closed and this one also will be closed. So they are responsible for the reset and enable. So now both the counters are enabled, okay. Now suppose at that moment of time the indicator IN001 is also closed, but CR20 is not going to be energized, that is indicator, because CR18 and CR19 the status is both are false, okay. They are going to be true only when it counts 6 number of object by the IN002. So suppose IN002 is receiving 6 number of pulses. After receiving 6 pulses, CR18 is going to be energized, and suppose CR18 is going to be energized, and after receiving 8 number of pulses, CR19 is going to be energized, and at that moment this is going to be true in the run, and then at that moment you will find that CR20 is going to be energized. So this is the AND logic we put. So whenever 6 and 8 are received number of pulses or number of object, then only CR20 is going to be energized. So this way we can build the ladder logic for this problem, okay. Now another problem is very interesting, that the example concerns keeping track of the net number of parts on a conveyor. The number of parts going on the conveyor is counted by the proximity devices count. The number leaving the conveyor is counted by a second proximity devices count, and each proximity device feeds information into its own counter function. The total net count is kept in a holding register common to both counters. Means here we have the conveyor. So now suppose here one sensor is there, which is IN002, which is keeping the count how many parts are coming, and here another counter we have, or sorry, another sensor we have, IN003, which is actually responsible for generating the pulses as the parts are leaving. Now what we want to know, that at any point of time we want to know on the conveyor how many number of objects are there, how many number of objects are, or how many number of parts are there, how we can develop the logic. So logic is that here definitely we have to use two counters, fine. So here we will use for counting the number of parts coming in, we will use a up counter, and the parts which is coming off, we will use a down counter. And the thing is that what should be the preset value for each of the counter. Another thing is that another important thing is that for both the counter, the address of the accumulator we will take the same. Accumulator registers will be same. So then only by reading the accumulator register we can have the knowledge how many number of parts will be at a time on the conveyor. Let us see the ladder diagram or ladder logic and try to understand how it will be. Okay. So suppose IN001 is the master switch. So IN001, if it is on, then we have used for the parts on count, that is CR18, and which is a up counter UC, and down counter we have used, that is part off count. And very important thing is that you see for both the cases we have taken HR001 as a accumulator register. Both address is same, but the preset value for the up counter, which is responsible for counting how many parts are coming in, we have set to a very high value, 999, maybe the maximum value or maximum counts it can do. Okay. And what should be the preset value for the down counter? Now preset value we will set for the down counter, that is the initial count of the parts on the line to start. Means suppose initially we found that three number of parts are there. Okay, suppose here 3 parts are there. Okay, so now so this is the down counter and this is the up counter, fine. And then the reset value we will give 3. So once the reset value you will give 3, you will set the 3, that is the content of the preset value. Okay, preset value, fine. And then if it is 3, then we will start, we will have the register content HR101 is also 3, because its down counter is preset value 3, means the content of the HR101 will be 3, because down counter operates by the decremental logic. So once this is HR is set 3, so for the up counter also you will find that the register value also will be reflected 3. Now suppose here the 4 number of counter pulses have been received by the first up counter. Okay, so what should be the content of the register HR101? So it is going to be incremented by the 4 pulses. So now at that moment of time, what will be the content of the register? That is, previously it was 3, now the count has been 4, so it is 7. Okay, and suppose at that moment of time the 2 number of objects have left. So then what will happen? The register content of 101 will be decremented by 2. So Now 7 minus 2, that is equal to 5. So at that moment of time you will find that basically on the conveyor 5 number of elements are, or 5 number of objects are there. So in this way, at a time, if we want to know that how many number of objects are there on the conveyor, we can use this logic to develop. Okay, so here the same explanation is given, and you will find that this kind of logic having very relevant application, that a counter might be used to keep the track of the number of vehicles in a parking lot. As the vehicles enters the lot through a entrance gate, the counter counts up, and vehicles exit the lot through an exit gate, the counter counts down. When the lot is full, a sign at the entrance gate turns on, indicating that lot is full. So at a time, if you want to know that how many number of vehicles are inside the parking lot, we can achieve by using this kind of ladder logic. Okay, so next example we are going to discuss, that is count and time. Means we are going to use the counter and timer simultaneously to develop the ladder logic, or to deal the problem what it is stated. What is that? After a count of 15 items from sensor, a pen spray is turned on for 25 seconds. After 25 seconds, pen spray should off. Use on delay timer. Okay, so after counting of 15 items from the sensor, a pen spray is going to turn on. So let us understand this one. So here one timer. So now you see by the format you can understand which one is the timer and which one is the counter. Okay, here you see it is count 15, here it is time 15, and also it is UC001 and it is TS001. Okay, and this switch is responsible for count, and this switch is responsible for run. Okay, for time. So now if the IN001 IN007 is closed, okay, and also at the same time IN008 is closed. Okay, now what is the meaning of that? That IN007 is going to receive the 15 number of pulses. Okay, once it is going to receive the 15 number of pulses, then only the UC001 is going to be activated. So once the UC001 is going to activated, at that moment of time the UC001 and UC001 both the that is time and reset will be activated, and once it is activated, at that moment of time the TS002 is not going to be energized. It is going to be energized after 25 seconds. So once the timer counts the 15 number of items, then in the last logic UC001 is going to be closed, and then the CR87, which is the spray, is going to be on at that moment of time, and on that moment of time the timer is also activated, but the TS002 will be activated after 25 seconds. Means after 25 seconds this logic is going to be false, so CR87 is going to be stopped. That's spray is going to be stopped after 25 seconds. So only duration after counting 15 number of items, the definitely the spray is going to be on, and it will be on for only 25 seconds of time, and after that it is going to be off. So this is the way we can develop the ladder logic. So now here actually this page I kept blank because you can draw the timing diagram for this. This will be very useful for you, that the timing diagram of the timer, counter, what it is going to have. So timer, what you will do, the timer, suppose it is going to receive the 15 number of pulses. Okay, this is suppose 15 number of pulses. So during the 15 number of pulses, what is going to happen to the TS02? So TS02 is TS02 is still going to be off. It is going to, so suppose timer TS02 is going to be off, and what will happen after counting the 25 number of pulses? Okay, so CR87, which is the spray, is going to be activated here. Okay, so this is CR87, you can say. Okay, now after 25 seconds, what is going to happen? Now this is going to be on. Once it is going to be on, suppose this is the time, that is 25 second, okay, and then what will happen, this is going to be off. So this is the way you can develop the timing diagram. Fine. Now delayed counting process, a process where a counts of events is to be start after a fixed time interval. Let us read the problem statement. Suppose we have to count 150 items. After counting 150 items, an indicator should glow, but this counting process will start not immediately after pressing the switch IN001. The counting process will start 1 hour after the IN001 closes. So this is very simple. So here we have used a timer as well as a counter. So the timer, the preset value is 3600 second. Okay. Now here important thing is that in the down counter we are using the down counter where the preset value is 150. Fine. And here if you see that at the counting line we have IN002 which is responsible for the pulses or counting, and TS008 which is the timer address which is used to make that if the IN001 is closed and IN003 is enabled, okay, so both the timer and counter is enabled simultaneously, then what will happen, that suppose it is going to receive the pulses, okay, it is going to receive the pulses, IN002 is receive the pulses, but the time counter is not going to work because this TS008 is normally open. So this is going to be closed only when that the TS008 will be energized after 1 hour. Whenever after 1 hour it is going to be energized, then it is going to be closed, and then only the down counter is start to count 150 number of items. So counting will start not immediately by pressing the IN001. Instead of that, it is going to start after 1 hour. Okay. Now the last example, that is rate determination. How many parts per minute are going past a certain process point? Suppose a conveyor belt is there, and you want to know that per minute how many number of package or how many number of items are passing through. Okay, so that you want to, so that is called the rate determination. So let us see this. So here also we are using timer and counter. So here one timer we are using, that preset value is 60. Fine. And the timer what you are using, the counter we are using, the preset value we have arbitrarily set very high because we don't know that in a minute how many number of items are going to be received. Fine. So now you see the switches, that is very interesting. So whenever IN60 is closed, this also will be closed, means both the timers as well as the counter will be enabled at the same time. Fine. Now whenever the IN727 is energized, then this timer starts to count, okay, which is preset value is 60 second is given. So whenever it is closed, this is also closed, and TS722 is also closed, which is true here at that moment of time because this TS72 is going to be energized only after 1 minute. So now whenever the 27 is closed, okay, then what will happen, suppose the counter is going to receive 150 number of item. Once it will receive the 150 number of item, which will be recorded at HR106 within the 60 minute of time. So then after 60 minute, exactly after 60 minute, what will happen? The TS72 will be energized, which will make this rung false. Means even if the pulses received by IN61, that is not going to be registered in the register value or accumulator value of the counter. Means within a 60 minute of 60 second of interval of time, whatever the pulses will be received by the up counter, that will be stored in the register. So that's why it is at closing IN27 starts timing and counting. After 60 seconds, counting stops. HR106 contains the count for 60 seconds, the rate per minute. To reset, what we have to do, open IN60 and reset HR106 to 0000. So if you reset it, it is going to reset. And again, the next, suppose if you want to know that in a 60 second how many number of items are going to be received, then you reset the counter. Okay, so this way we can develop, or we can solve certain industrial problem using counter and timer applications. Okay, so here the explanation is given. So at this point I will stop. So now today we have discussed that how the counter is going to operate, and then we have certain application we have seen where solely we have used the timer, and also we have used the timer as well as solely we have used the counter, and then we have seen that how the combination of the timer and counter can act together to solve certain problem. Okay, thank you.